Good day, very good students, viewers. We are in quarter 2, 8 of our session entitled The Equivalence of a Statement and its Contrapositive, the Converse and Inverse of a Statement. So last time we talked about conditional statement, converse statement, inverse statement, and contrapositive statement. So which among the four are equivalent? That's our topic for today. But before that, let us have first our short activity. So the goal for this topic will be illustrate the equivalences of the statement and its contrapositive, the converse and inverse of a statement. For our first activity, we need to write or we need to tell whether the following are considered statement or not statement. By the way, let us recall, in Filipino, statement is end with period. Okay, while if the statement doesn't end with period, therefore it's not a statement. Okay, so how about in perspective of mathematics? How does a statement define? So let us have first the first question, the first statement. The sun rises at east. So is this a statement or not? So the answer is statement. The second one, wash the dishes. Is this the statement or not? Okay, this is not statement. So later we're going to discuss why number 2 is not a statement. Number 3, Cha Yun-woo is one of the cast in Korean drama True Beauty. Statement or not statement? Okay, the answer is statement. Number 4, Team Brand won the esports battle. Statement or not statement? So the answer is statement. TikTok. Okay, of course, this is not a statement. So, how are we going to define statement? A statement is a declarative sentence that is either true or false, but not both. Statements are usually denoted by small capital letters, PQRS, and so on. Okay, so if we're going back to our previous activity, number 2, wash the dishes. Wash the dishes is not a declarative sentence. Okay? It is a sentence that asks you to do a favor. And if we continue, that is either true or false. Wash the dishes, true. Either you do it. Wash the dishes, false. You don't do it. So if 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 it can be true, it can be true or can be false. If that is both true or false, therefore it is not a statement. So meaning to say a statement is only a sentence that is tells about facts uh, that is only true or only false. So number 2 is not a statement. Okay, what else? The statement number 4. I guess it's statement number 4. Let's go back. Statement number 4. Okay. Only number 2 is not a statement. Okay. So, let's discuss further. Example number 1. The following are statements. Taal volcano is in Talisay, Batangas. So, if you're in the Philippines, Taal volcano is located in Talisay, Batangas. So, this is fact. This is true. June 12 is a Philippine holiday. So if you're going to look in a calendar or if you Google it, June 12 is a Philippine holiday. 7 is greater than 24. 7 is greater than 24. So this is false. This is a statement because it is only false. Number 4, 16 minus 9 is 14. This is false as well. The following are not statements. What should I bring in the camp? Of course, you cannot answer that by true or false. Pass the soup. It can be true, it can be false, it can be both. All right. You cannot determine if it is true or false. Okay, x plus 5 equals 20. Oh, why this is not a statement? The last one is not a statement. Because you're going to solve for x. You're going to get the value of x. It cannot be determined by true or false. The conditional statement P implies Q is false only when P, or the hypothesis or premise of your statement, is true, and Q, the conclusion or consequence, is false. For example, for a conditional statement, if the angle is 90 degrees, then it is a right angle. So P, the angle is 90 degrees, that's your hypothesis. Q, it is a right angle, that's your conclusion. So we're going to use the truth table. You have here P and Q, and P implies Q. So let's list down the four possibilities. If P is true and Q is true, the whole statement P implies Q is true. If P is true but Q is false, P implies Q is false, according to the definition last time, a while ago. If the hypothesis is true but the conclusion is false, the whole statement, conditional statement, is false. If P is false, Q is true, P implies Q is true. If both statements are false, the whole statement is true. So these are the possible truth value of our conditional statement. Now, which of the following statement is equivalent to our conditional statement? If the angle is 90 degrees, then it is a right angle. Letter A, if it is not a right angle, then the angle is 90 degrees. This is not Q implies P. We have no not Q implies P in our previous lesson. If it is a right angle, then the angle is 90 degrees. This is what? The converse of our statement. Okay. Letter A, if it is not a right angle, then the angle is 90 degrees. So letter A is, I think it's a typo error. Let me check first. Then the angle is not. Pardon. Pardon for the typo error. It is not. Because not P implies not Q. Okay, so later we're going to discuss why is it why they are equivalent. Okay. So the equivalent statement is, if it is not a right angle, then the angle is not 90 degrees. So that is the contrapositive of our statement. Not Q implies not P. So equivalent statements are statements that are written differently but hold the same logical equivalence. So as you can see, the equivalent statement is in negation form. Not Q implies not P. And the equivalent, as stated a while ago, that's P implies Q. So let us find out. So we have the statement, if P then Q, then the equivalent is if not Q then not P. That's the rule. So not P is a negation of a statement wherein you're getting the opposite truth value. So if you have negation, you're dealing with getting the opposite truth value of our statement. So not P, so that the symbol tilde here, not P, is read as not P. So let me arrange the statement. It's not written quite again. This is the angle. Okay. Then it is not. Then it is not a right. Then it is not a right angle. Okay. So let's have first our conditional statement. If the angle is 90 degrees, then it is a right angle. P, the angle is 90 degrees, not P. The angle is not 90 degrees. So take note, class, in negation, you just you just add the word not. You just add the word not. You cannot get the opposite or the antonyms rather, the antonyms of the statement. For example, beautiful, ugly. We have we have no such We have no such rule for that in mathematics. So if the P is beautiful, not P is not beautiful. That's how we do it. Okay. Q. So P, if P is true, not P is false. If P is false, not P is true. Then Q, if it is a right angle, it is not it is a right angle. So Q, not Q, it is not a right angle. So for Q, you have true. If Q is true, not Q is false. If Q is false, not Q is true. If the angle is not 90 degrees, then it is not a right angle. So P, the angle is not 90 degrees, not P. The angle is 90 degrees. So if P is in negation form, the not P, in not P, you will remove the word not. So P, if P is true, not P is false. If P is false, not P is true. So you hold the same truth value. If Q, it is not a right angle. Q, it is not a right angle. And it is not a right angle. So Q, it is not a right angle. So not Q, it's redundant. Q is not a right angle. So for Q, it is a right angle. So if Q is true, not Q is false. If Q is false, not Q is true. So for negation, the negation of truth statement is false, and the negation of false statement is true. And so you just get the opposite of the truth value. For the conditional statement, if the angle is 90 degrees, then it is a right angle. Contrapositive, if it is not a right angle, then the angle is 90 degrees. So not Q and not P. So a while ago, we had the logical equivalent, we had the truth value for conditional statement. So this is the conditional statement. If the angle is 90 degrees, then it is a right angle. For not P, so we get the negation of Q. So you have here false, true, false, true. For not false, false, true. So if have not implies P, you have here true, false, true, and true. So for the contrapositive statement, if it is not a right angle, then the angle is not 90 degrees. Okay, take a look at the logical equivalence of P implies Q and not Q implies not P. What can you say about that? Logically, the truth value. They hold the same arrangement of truth values. So true, in P implies Q, you have true, false, true, true. In not Q implies not P, you have true, false, true, true. So therefore, there are logical equivalent. Okay, so if we're going back on our statement, P and Q is true, not Q and not P, not Q and not P here is false. So they belong in the first column, first row rather. And so the truth value here, you have P is true, Q is true, P implies Q is true. And then not Q false, since Q is true, not Q is false. If P is true, not P is false. So not Q implies not P is true. For number 4, the conditional statement, if the angle is not 90 degrees, then it is a right angle. So I still identify P and Q. For contrapositive statement, if not Q, then not P. If it is not right angle, then the angle is not 90 degrees. So pardon, it's not 90. Let me change that one. Angle is not 90. Not 90 degrees. So if P is true, in conditional statement, if P is true, Q is false. If not Q is true, not P is false. So they belong on the second row of our conditional, on our logical equivalences. Okay. So let's go back in conditional statement. If P is true, but conclusion is false, P implies Q is false. In contrapositive statement, since not Q become the hypothesis, so true, and not P becomes the conclusion, so false. So therefore, not Q implies not P is false. As you can see, they hold the same logical, the same truth value. The conditional statement P implies Q is false only when P, the hypothesis or premise, is true, and Q is the conclusion or consequence is false. For converse statement, Q implies P is false only when Q, the hypothesis or premise, is false, and P, the conclusion or consequence, is true. So let's have our converse statement if Q then P. If it is a right angle, then the angle is 90 degrees. Q, it is a right angle. P, the angle is 90 degrees. The inverse statement, if the angle is not 90 degrees, then it is not a right angle. Not P, the angle is not 90 degrees. Not Q, it is not a right angle. So if we talk about the logical equivalences, this is the converse statement. This time, it is Q implies P. So meaning to say, the Q will become hypothesis and P will become the conclusion. So you have here, both statement is true. This one, it will become true because Q is now hypothesis and P will be the conclusion. So false going true. So this is true. This one is false because Q will be the hypothesis and P will be the conclusion. So true going false. Then this one is true, both true. Not P implies not Q. So you get the negation of the previous statement. And so this is the logical, this is the truth value where converse statement becomes false. So if we negate not P, false, false, true, true, false, true, false, true. So not P implies not Q, that would be true, true, false, and true. Okay, so this is the logical equivalence for, this is the truth value for inverse statement. Okay, so as you can see, Q implies P and not P implies not Q holds the same truth value. Q implies P got true, true, false, true. Not P implies not Q got true, true, false, and true. So if P here is true, not P is false. If Q is true, not Q is false. So they belong on the first row of our table. So if we take the first row, as you can see, if we look closer, Q implies P is true, not P implies not Q is true. Let's have the three statements, P, Q, R. The squares and rectangle have four sides. It is quadrilateral for Q. R, the sum of its interior angles is 360 degrees. So PQR, true, false, true, 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 false, true, false, true, 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 false, true, false, 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 and true, false, true, true, and false, false, false. Okay, so we have three statements. So how many possible truth value do we have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 possible answers. So the formula for this is 2 raised to p or 2 raised to n. Why is it 2? Why the base is true? Because why the base is 2? Because there are only 2 possible answers, which is true and false. Then X will be the number of statements. So a while ago, we have two statements. So 2 raised to 2, 2 times 2 will be 4. So you have 4 possible truth value. Here we have 3 statements. We have 8 truth value, 8 possible truth value. So what is P implies R? For conditional statement, if the square and rectangle have 4 sides, then the sum of its interior angle is 360 degrees. So take note, when we get the logical equivalence of this, we cannot take all the 3 statements. We will deal with 2 statements at a time. So P implies R. So this is your P implies R. You get P. You get the truth value for P and truth value for R. So let's go back to our previous here. So you will omit P. If you want P implies R, you're going to get only for the column of P and column of R, then get the logical equivalence. So what is P implies R? So P implies R is true, false, false, true, 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 and true. Okay, so even we have 3 sentences, 3 statements rather, even we have 3 statements, we still apply the condition for the false statement of P implies R. So P implies R is only false if P is true and R is false. Conditional statement, if P then R. So if P is true, R is true. Therefore, they hold the first row of our statement. Not R implies not P. So not R if the sum of its interior angle is not 360 degrees. Not P, it is not a square and rectangle that have 4 sides. So we take the negation of not R and not P. We take not R and not P. So we negate all truth value of R and truth value of P. So we deal with not R. Not P, you have false, 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 true, true, true. Okay. So not R implies not P. You have true, false, false, true, 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 true. So as you can see, even we have 3 statements, they still hold. They still hold the same logical equivalences. So P implies R got true, false, false, true, 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 true. Not R implies not P got true, false, false, true, 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 true. Okay. So not R. So our first statement, so our statement here holds the first row of our column. Okay, so for your activity, by the way, if you have question, you can drop it in our comment section. So in our activity, fill the truth table of the following statement. So for the conditional statement, if we add the 2 even number, then the sum is also even. You have here P is true, Q is true. So what is P implies Q? What is not Q? What is not P? And what is not Q implies not. Okay, so this is our answer. P implies Q is true. Not Q. Sorry, it must be false. Not Q, not P is false. Not Q, that's false. This statement is false. Not Q, not P is false. Let me insert a text box. So that's false. And that is false. Okay. Because you're going to negate the statements. Yeah. Okay. So this is our answer. False, false. Not because Q is true, not Q is false. P is true, not P is false. The converse statement, if the sum is an even number, then we add two even numbers. So if not P is false, not Q is true, what will be the other logical equivalence of other statement? So you have here, not P, not P is false, so P is true. Not Q is true, uh, Q is false. So Q implies P, Q will become the hypothesis and P will become the conclusion. So false going true, Q implies P is true. Not P implies not Q, that's also true. Okay, for the conditional statement, if your temperature is 37.5 degrees centigrade, then you have a fever. Not Q is false, not P is true. So our answer is P is true, Q is true, P implies Q is true, not Q implies not P is true. For the converse statement, if you have a fever, then your temperature is 37.5 degrees centigrade. P is true, Q is false. So our answer, Q implies P is true. Not P is false, not Q is true. Not P implies not Q is true. For the conditional statement, if the delivery did not arrive, then the cargo is still in process. Not Q is false, not P is false. Okay. Oh, baliktad. This is false. So P is true, Q is true. P implies Q is true. Not Q implies not P is uh, true. Okay. Let me borrow this one. I will fix it here. We place it here. Yeah. Okay. I think it's good. Okay. So not Q imply not Q is false, not P is false. So keep in mind that in our conditional statement and contrapositive statement holds the same logical equivalence. So you have true, false, true, true. For the converse statement, if Q then P, you have true, true, false, and true. For the inverse statement, still the same, true, true, false, and true. So for your questions and answer, please drop it on our comment section. If you don't have, if you want to add some more, feel free to uh, drop it in our comment section. See you next time. Bye-bye.